to discuss about heat capacity, constant pressure in terms of partition function. Before entering the derivation part, we need some prior knowledge. They are the heat capacity at constant pressure, Cp equal to dou H by dou T, then partition function at constant pressure, delta equal to sigma I e raised to minus beta into Ei plus PVI. Then Gibbs free energy G equal to minus kT into log delta. Then entropy S equal to minus dou G by dou T. Here comes the derivation part. From thermodynamics, we know G equal to H minus Ts. Therefore, H equal to G plus Ts. Then G equal to minus kT log delta. S equal to minus dou G by dou T constant pressure P. Substituting the expression for G and S, we get H equal to minus kT log delta plus P into K log delta plus K into T dou by dou T log delta at constant pressure P. The first two terms will cancel, so we get H equal to kT square dou by dou T of log delta into at constant pressure P. This is the statistical mechanical expression for enthalpy. Now we know Cp equal to dou H by dou T at constant pressure P. By substituting the expression for enthalpy from equation 6, we get Cp equal to dou by dou T of At square dou by dou T of log delta constant pressure P. Using the product rule, we get Cp equal to 2At into dou by dou T of log delta plus At square dou square by dou T square of log delta, where delta is the isothermal isobaric partition function. So this is the expression for the heat capacity at constant pressure in terms of partition function. Now here comes an important part. How the G means Gibbs free energy equal to minus kT log delta K. This relation is not from thermodynamics alone. It came from statistical mechanics by extending the canonical ensemble to the isothermal isobaric NPT ensemble. Derivation part is for a system at constant number of particles and volume and temperature, the canonical partition function is z equal to sigma I e raised to minus beta ei, where beta is 1 by kT. The Helmholtz free energy F is related to partition function Z by F is equal to minus kT log Z. This is the standard result in statistical mechanics. Move to the NPT ensemble, that is constant number of particles, constant pressure and constant temperature. At constant pressure, the volume is no longer fixed. Therefore, we must include the pressure volume work in the energy. So the quantity that appears in the Boltzmann factor becomes Ei plus PVA. Hence, the partition function changes from Z to the isothermal isobaric partition function delta. So delta equal to sigma I e raised to minus beta into Ei plus PVA. Since NPT ensemble has constant pressure instead of constant volume, the natural thermodynamic potential is the Gibbs energy. Therefore, Gibbs energy G equal to minus kT log delta. Constant volume F is equal to U minus Ts. Constant pressure G equal to H minus Ts. So G becomes U plus PV minus Ts. Because the Boltzmann factor in the NPT ensemble contains E plus PV. The corresponding free energy is G, not F.